Right, question 15. So, just a question about curves. It's a quadratic and a cubic curve, isn't it? So, verifying that x equals 1 when C1 and C2 intersect. Well, all we need to do here is say, right, okay, so when x equals 1, if they intersect, y is going to have the same value. So all you need to do is substitute for C1, x equals 1. So y is going to equal 8 minus 10 times 1 plus 6 times 1 squared minus 1 cubed. And if you put all of that in, you've got 8 minus 10 plus 6, take 1, gets you 3. And then for this one, you've got y equals 1 squared minus 12 times 1, we could just put 12, plus 14 is also equal to 3. So because they're both that, you can even say intersect at 1, 3, but this is what you're getting the marks for, showing that they both produce the same number. Right, so the curves also intersect when x equals k. So we've got two curves. One of them's a quadratic, the other one's a negative cubic, so it's doing maybe something like that. So we've got a point there and a point there. And they're going to intersect when they're equal to each other. So the first mark you're going to get is just for writing the two equations equal each other. So x squared minus 12x plus 14 equals 8 minus 10x plus 6x, take x cubed. Then, as ever, we want to make the whole thing equal to 0 and factorize. So if we add x cubed to both sides, we've just got x squared there. We've got negative 10 plus 6 is negative 4x. Add 4, so you've got that gives us negative 4x. So if we add 4x to both sides, sorry, I'm talking nonsense, aren't I? That is 6x. Let me write all of that again. 8 minus 10x plus 6x squared. So always taking care to copy down what we've got there carefully, folks. Then I'm going to add x cubed to both sides. I'm going to take 6x squared from both sides, giving me minus 5x squared. I'm going to add 10x to both sides, giving me negative 2x. I'm going to take 8 from both sides, giving me positive 6 equals 0. Then I need to factorize this. Now I know one factor because I know it crosses when x equals 1. So if x equals 1 is true, then that means the bracket x minus 1, where the bracket is equal to 0, is a factor. So then I'm going to need to do some algebraic division of this expression by x minus 1. X goes into x cubed, x squared times x, x cubed, negative 1 x squared. Then I'm going to take that from that, take a negative means adding 1 gives me negative 4x squared, so this is where I've got to be really careful with the negatives. Pull down the minus 2x, divide x into negative 4x squared gives me negative 4x, multiply by that gives me negative 4x squared. Negative 4x times negative 1 is positive 4x. Take this line from that line. 4 from negative 2 is negative 6x. Pull down the plus 6. Divide x into negative 6x gives me negative 6. Check this all works out. Negative 6x, negative 6 times negative 1 is positive 6. Take that from that gives me nothing, which proves x minus 1 is a factor. But it also means we've now got x minus 1 x squared minus 12x plus 14 equals 0. So the next thing to do is we need to factorize this. Now, remembering it says we want to have an intercept where it's k, and k is smaller than 0. So we're going to expect to get two factors when we factorize x squared minus 12x plus 14, and it says the exact value of k, so it's unlikely that this is going to factorize. 7 times 2 is 14, isn't it? Difference between 14 and 1 is adding them together, so that's not going to be 16, or no, it doesn't factorize. So we're going to need to use the quadratic formula. So x is negative b, so that's plus 12 plus or minus the square root of b squared, 12 squared, minus 4 times 1 times 14, all over 2 times 1 is 2. And if you whack that into the calculator, we should get 2 plus root 10, or 2 take root 10. But we want it to be less than 0, don't we? And if we add two positives, we're going to get a positive number. The square root of 10 is going to be a bit more than 3, so that's going to be a negative value. So for that reason, we can say that k, we can cross that one out and say k equals 2 take root 10.